Well, I'm back. So after looking at the homework for section 12.4, I've already recorded the lecture, and I realized there's a couple of examples that I didn't cover in the lecture, so I'm going to go over that right here. So one is, you've got this wrench trying to loosen or tighten this bolt right here, the nut. It could be a bolt, but looks like a nut. Anyway, and you're applying force in this direction at 45 degrees. The force is 16 pounds. And, ooh, you got to watch out for things like this. Look at this. This is 10 inches, and in the answer it says it should be in foot-pounds. So I need to change this. I automatically need to change this to 10/12 of a foot. Okay. Now, let me explain what's going on. So here's the bolt or the nut. Then this is the wrench. And usually this is called R because it's R radius of a circle. Because if you could spin it all the way around, you'd be making a circle. All right. And you could even view that as a vector. And then you're applying force like this. Now, in order for this thing to move, we want it to go this way. We want it to go down. So the moment that it moves, it's going to be going down. Of course, since it's attached, it's then going to start going around. But we really want this thing to move down. We don't want it to move out at this angle, because then it would become unhinged. So we really want to know how much of the force is going down. So this is the force vector, but we want to know what component of that or how much of that is going down. So for the moment, I'll just call that y. And I could take this vector and move it over here and actually make a right triangle. So how much of the force is going down? So if this is an angle theta, then I could use sine. So sine of theta equals opposite over hypotenuse. So sine of theta equals y over f, and then solve for y. So this is the amount of force that's going to be going down. Now for torque, which is the force that we're talking about, torque is force in a rotational setting. Well, it's basically like work, and work equals force times distance. So the distance would be the length of this thing. The longer it is, the less force is required. If it's shorter, it's going to take more force. So you need to know the length of the R. And then right here, I was being a little bit sloppy. I should have said the length of the F times sine of theta. So that's one way to do it. Now, because of the formula that we had in this section, that sine of theta equals the cross product divided by the length, you could also replace this with the length of R cross F, and it'll give you the same answer. Okay, now let's try to apply that here. So the R is this length right here, and that's the one that we had to change. So this is 10/12 of a foot. And then this is the F, but it's going at this 45-degree angle. So that's where we need to drop this and then use sine. So torque will equal the length of this, which is 10/12 in feet, and then times the magnitude of the force vector, so that's 16 pounds. But not all of that is going in the down direction, so you need to multiply by sine of 45 degrees. Let's see. So that is 10/12 times 16 times sine of 45 degrees. 9.428. So in here, they said round to 2 decimals, and because I have the teacher's version, it fills in the answer for me. So they said 9.43, so if you round it, that's correct. Now, if you were to do this with vectors, so basically one vector, okay, so one vector is just this. So we'd be looking at like, this is the y-axis and this is the x-axis, and z would equal 0. So for this vector right here, that vector would be 10/12 for the x component, and then 0, and then 0. And then for this vector, that would be in the x direction, so that would be the bottom. So if you go through that little right triangle that I did just a minute ago, that would actually use cosine instead of sine. So that would be 16 cosine of 45 degrees for the x part. The y part, that's where I use sine, so that would be 16 sine of 45 degrees. And then the z would be 0. And then if you do the cross product, see, this part right here is amazing to me, because if you look at what I'm writing right here, it looks nothing like this. And yet, at the end, the answer will turn out to be the same. So then you take these two vectors and do the cross product. So cross out this, and when you cross out this, that's going to be 0 minus 0. When you cross out this, that's going to be 0 minus 0. Oh goodness. And then when you cross out this, oh, finally we get something. This one times this will be 10/12, and then 16 sine of 45 degrees. And then when you do this diagonal, it's 0. And then when you find the length of that vector, you take the square root of 0 squared plus 0 squared plus this 10/12 times 16 sine of 45 degrees squared. And once you eliminate these zeros, because they don't add anything to the problem, that square and that square root are going to cancel out, and you get the same thing as this. So they are the same. Now on to one other question that I did not cover in the lecture part. Parallelepiped. What is a parallelepiped? This is a parallelepiped. So basically, each side is a parallelogram. So this is a parallelogram, this is a parallelogram, etc. Now the way that you can make one of these things is take any three vectors that are not in the same plane. So you could take this vector, and let's say that one's A. And then take this vector, let's say that one's B. And it really goes all the way across, but you get the idea. And then this vector, and then that one's going to be C. So then, how do you find the volume? Well, in order to find volume of a shape, you basically find the area of the base, and then you multiply by how tall it is. Well, the area of the base, this is a parallelogram. So the area of its base is the cross product of B and C. Then to multiply by the height, you then take the dot product with A. So the volume will be A dot product with B cross C. It's called a triple product. You are taking all three of them. And the order doesn't matter, because if you looked at it as, well, I will find the area of this wall over here, well, then you would take the cross product of A and B and then dot product with C. So the order doesn't really matter, as long as you cross product two of them and then dot product with the other one. Now let's go back to this homework question. So it's given by these points, and I need vectors. So what I'm going to do is I'm going to have all the vectors go from 0, 0, 0 to that point, because that way the vector that goes from A to B means you subtract this minus this. So 2 minus 0, 1 minus 0, 0 minus 0 means that it's just 2, 1, 0. All right, so this is going to be the base point. Now go from A to C, and then that basically just turns the point C into a vector. 0, negative 4, and 1. Then go from A to D, so that will be 4, negative 6, 7. Okay, so now I need to pick two of these vectors. I'm going to pick this one, and then do the cross product. And when I'm done with the cross product of these two, then I do the dot product with that, and I should get the number 40. So let's see. Here's the I, J, K, 0, negative 4, 1, 4, negative 6, 7. Now the way that I do it is I speed things up. The very first time I showed you, I wrote out the 3 small determinants with an I in front of one, and then a J, and then a K, and I showed every step. Well, you can really speed things up because you cross out the I, and then this is going to be negative 28 minus a negative 6. Negative 28 minus a negative 6. Then cross out this middle one, and that's going to be 0 minus 4, which is a negative 4. But remember, you need to change the sign on the middle one. So it's 0 minus 4 is negative 4, but change its sign, it's positive 4. And then for this one, that would be 0 minus a negative 16 is positive 16. So this becomes a positive 6, so that's going to be negative 22, 4, and 16. And then we're almost done. So now just take the dot product of this one and this one. So the dot product of 2, 1, 0 and negative 22, 4, 16. So 2 times negative 22, that's negative 44. A 1 times 4, so 1 times 4 is 4. And the last one is going to be 0 times this, so that's 0. And so I get the answer that it's negative 40. But of course, volume cannot be negative. So back here, I should have emphasized you need to take the absolute value. So take off the negative, and the answer is 40, just like the homework said it was going to be.